This is Ward Davis and Drew Freeman's SRP project. On today's project, we're going to be talking about the science behind baking brownies. The first step in making these brownies is to put the mix into the mixing bowl. We are using Ghirardelli's brownie mix. We have decided to make 2 batches of these brownies because that is all the mix we have. We only have 2 bags. Therefore, since we have an abundance of the other ingredients, the brownie mix will be our limiting reactant. These came in pre-packaged bags, so we did not have to measure them out. We just knew how to put 1 bag in for 1 batch. However, each bag weighed about 1 pound, so there's about 1 pound of mix in each batch. Once we were done putting the brownie mix into the bowl, we had to do the next step. The next step was to add the oil. The brownies wanted vegetable oil, however, we used canola oil since we found it was a good substitute for it. Here you can see me adding the canola oil into the brownie mix. The recipe called for 2/3 of a cup of canola oil. However, we wanted 2 batches, so we had to double that. We did the math and we knew that would be 4/3 cup of canola oil. We had used the skill of measurement that we learned in chemistry in order to measure this all out, and then we poured it into the brownie mix and waited for it to combine with the rest. The next thing we had to do in order to achieve brownies was to add water. Water is very essential for life on Earth, and we've learned in chemistry class that water is a hydrogen bond, since the chemical formula for water is H2O, and anything with hydrogen and oxygen will become a hydrogen bond. Here you can once again see the ever-important skill of measuring that I learned in chemistry class to measure out 4/3 cup of water. I then continued to put this into the brownie mix along with the canola oil in order for it to be mixed later and make brownies. The next step in order to make brownies was to mix everything together. However, we messed up because we forgot to put eggs in before we mixed it together, and we only had the water, canola oil, and brownie mix. However, this did not matter because before we put it in the oven, we remembered to put the eggs in, so no chemical change had come, so we were fine. In this video, you can see Ward try to mix everything together. At the beginning, this was very hard because the brownies were very dense. Density referring to the amount of stuff in a given material, which is a term we learn in chemistry. It's very dense, so it's hard to get everything together because it's hard to put the strength required. Mixing this all together is only a physical change and not a chemical change, because a physical change does not change any of the elements, and this does not change any elements, and you can revert it back if you tried hard enough. Eventually it becomes easier to mix together, and because as the water and canola oil get into the brownie mix, it gets more liquidy and less dense. This makes it very much easier to whip together and makes life a lot easier. The next step in order to achieve making brownies was to add eggs to the mix. Technically, we should have done this earlier before we mixed everything together, but it did not matter because only physical changes and not chemical changes had applied. It is important to add eggs to the brownie mix because in baked products, eggs provide structure, richness, color, and flavor to it. We learned this in our research in order to determine the chemistry in making brownies. In this clip, you can see me masterfully crack and add the eggs to the mix. I decided to add both eggs to the mix before whipping them together. And in this next clip, you're going to see Ward add eggs to the mix with a little bit of show. Here you can see Ward throwing and catching the eggs like the true master he is. He can also gritty, which is very impressive. He does this a while for no real point except for show. Now you can see him struggle to break open the egg because he's not very strong. Here he applies the egg into the mix along with my other 2 eggs. It's taking him a while because he does not have the experience of a master like me. He throws away the egg and then cracks open the other egg, which again takes him a long time. We finally put in 4 eggs, and we knew this because we used the chemistry skill of measurement. We then whipped it together. The next step to achieve a perfect brownie was to spray the glass cans in which you are going to cook it in. This is very important to the steps, so do not skip this. Here you can see Ward spraying the pans. Spraying the pans is important so the brownies don't stick. We know spraying the pans is important because Pam's, the baking company, uses chemistry to make sure the brownies won't stick to the pan. The next step in making brownies was to add the batter to the pre-sprayed pans. Here you can see me doing just that. I had to make sure that the same amount of batter went in each pan and that it was the same density all around. This was ensured that it baked evenly and some parts were not left overcooked and some parts were not left undercooked as well. This also helped the flavor because I had to make sure that the chocolate chips were moved all around the pan and not just in the center, which was a mistake I had made before. If all the chocolate chips are left in the center, then the crusts have no flavor and only the center parts are actually edible because the outside parts have no flavor whatsoever and taste like dried bread pretty much. The next step to making brownies is to actually bake the brownies by using the oven. By cooking in the oven, it removes all the moisture from the brownies, which makes them turn from a liquid batter into a solid brownie itself. It also melts the chocolate chips and all the chocolate, which will add flavor and make the brownie taste better. Be careful, it's hot. When you put the brownie batter into the oven and it starts cooking, this is a chemical change because when you apply heat, it makes the brownies change the element and you cannot change it back once the heat is applied and they are baked. This is different than physical change because a physical change, you only change it physically and not at a chemical level. And if you do a physical change, you can in fact go back and undo the change. You can now see the brownies after 20 minutes. You can see that they've risen a lot because the air bubbles in the brownie batter will dissipate and make the brownies rise once you apply them to the heat. Now you can see the brownies after 40 minutes of baking. Once again, you can see that they've risen from the heat. You can also tell this time that the phone gets blurry because the heat from the brownies in the oven is coming out and making the camera fog up from all the water and vapor in the air. Once you've baked them for an hour, your brownies are now done. The last step is to just take them out of the oven, as you can see I'm doing here. You've got to use pot handles because since the glass is a conductor, it gets hot when the oven heats it up, and if you touch it bare on, then you will burn yourself. Take them both out of the oven, and then once they cool, they will be delicious and ready for you to eat. If you bake it right, they will taste amazing. Now that you have your brownies, that is all that we have for you today. Once again, this is Ward Davis and Drew Freeman's SRP project, and we hope you learned a lot on how chemistry helps bake brownies and other baking goods. Thank you for watching, and we'll see you next time.